Okay, problem 21 says the graphs of 5 functions are shown below. Which function has a non-zero average value over the closed interval from negative pi to pi? So um, let's say that each of these functions is just called f. So let's think of, what's the average value of a function? Let's say your function is called f of x. So to find the average value of a function, you would find the value of the integral from a to b. In this case, a is negative pi to pi of your given function with respect to x. And then you divide it by b minus a, which would be pi minus negative pi, or 2 pi. So let's think about if we want this fraction to figure out when it would or would not equal 0, it really has to do with what does this integral equal? Does it equal 0 or not? So if the top of the fraction equals 0, the whole fraction would equal 0. So now let's look at the pictures. So you can see some pretty obvious symmetry here on part A, and I claim that if you were to evaluate this integral from negative pi to pi, you'd do it by evaluating this integral, and you'd get a negative value. So you'd get the amount of area there, but you'd get it in a negative form. And then you'd add this area right here, but it would have the same magnitude as the area over here, but it would be positive. So when you add all this up, I claim that you would get a 0 value for your integral, and hence a 0 average value for the function. So I would rule A out. Similarly, I would rule B out. So the amount of positive area, I'm speaking loosely here, looks like it's the same as the amount of negative area. So they would cancel each other out, and you would end up with a 0 value for your integral, and again, a 0 value for your average value there. Part C, it's, we could work harder at it, but, you could kind of look at this amount, and to me, they do look pretty congruent. And then the same thing here. So the amount of the positive value you get here looks like it's the same as the negative value you get here. So this one, it's a little less black and white. So I would kind of like softly rule it out. So let's give the ones that we know are out that symbol, and let's say like the maybe you're out symbol there. Okay, part D, same thing here. So if you look at this, would give you a positive value of some kind, and then this region right here would give you the same value but negative. So they would cancel each other out, and then the same thing would happen here and here. So D's out because the value of the integral would be 0. Now let's hard rule that out. Okay, part E here, if you were to look at, that value, that's a negative value, and then this value. So I claim that the value of the integral from negative pi to 0 here, because you have way more negative values for f, would end up being, the net value here would actually be negative. And then the same thing here, from 0 to pi, you have less positive area and more negative area. So the net value from 0 to pi would also be negative. So you'd end up with a negative value plus more negative values. So I would rule E in, which makes it easier to rule C out if you weren't sure about that. Okay, I also wanted to look at problem 24 here. So for problem 24, they give you the derivative, and they're asking you, they give you a value for the original function, and they want another value for the original function. My friends, the go-to move in this situation is going to be the fundamental theorem of calculus. So let's think about this. So we want information about f, but we have information about f prime. So what would you have to do to f prime to get f? You would have to take its antiderivative. So I'm just going to go ahead and say, boom, that in there. And then I would really like something that has the given information and the wanted information in the expression. So I'm going to look at the x values involved. I'm going to make those x values be the bounds, not necessarily in that order. You could go from 2 to 0 if you want to be fancy. And then let's interpret this. This would be f of your upper bound, take away f of your lower bound, simply because antiderivative of f prime is f. So they told you f of 0 is 1. You want to know what f of 2 is, and then this is something that we could use our calculator for. So, okay. So I went ahead and saved you the pain of watching me enter something in on my calculator. So I pre-entered it in, and then you could go math, function integration. Zero is one bound, 2 is the other. Evaluate your integral. And then now you have the value of the integral on the left side. Here we go. One more move, it's a little algebra 1, and you'd have your value for f of 2. Just add 1 to both sides. There we go, and you've got the answer, 8. There we go. Hope that helps.